Good evening, friends. In previous class, we have seen just now we have seen that steady flow energy equation for how to derive and steady flow energy equation for applying for flow process or open system process. Okay, so based on that steady flow energy equation, here we are going to apply for boiler, for nozzle, okay, for turbine, okay, for compressor. What is the steady flow energy equation for compressor? What is the steady flow energy equation for turbine? Okay, once you remember or recollect the previous steady flow energy equation where Q stands for, already given the basic assumptions or conditions. Why? Because the steady flow energy equation, the mass of the fluid is same in the entire system. The mass of the fluid is same in the entire system. At the same time, mass of the fluid means entering the system must be equal to mass of the fluid leaving the system. Mass of the fluid entering the system must be equal to mass of the fluid leaving the system. At the same time, there are no chemical changes. Okay, so these are the basic assumptions. At the same time, so based on steady flow energy equation also mainly we derived on law of conservation of energy. So here we already discussed about Q plus M into plus H stands for enthalpy, where H is equal to U plus P1 and Z1 G plus V1 squared by 2 equals to work. Okay, work plus M into H2 plus Z2 Z plus V2 squared by 2. Okay, so these things how we are applying. So you already know what is the basic condition of boiler. In boilers, water enters. So in coming classes you are going to study what are the boilers, what are the types of boilers. Okay, so there are two types of boilers: fire tube boilers and water tube boilers. The condition basic water entering the system and leaves as steam. Water enters into the system as liquid and leaves as steam. Okay, so here it is surroundings and there is a system inlet 1 and inlet outlet 2. Okay, so water enters as liquid and leaves as steam. Okay, so here the assumptions, what are the assumptions? The conditions means here, so work done is 0. Why? Because work done is considered in boilers, work done is 0. Why? Because heat directly, water directly converted to heat. Okay, and it is converted to steam. Okay, so work done is 0. At the same time, Z1 Z2 neglected. Why? Because I already told you the mass of fluid is entering the system must be equal to leaving the system. At the same time, mass of fluid is same in the entire system. So another parameter is kinetic energy V2 squared minus V1 squared by 2 is small, very much small. Okay, so based on these assumptions, now we are applying for this equation. So for any condition regarding boiler, what are the conditions? What are the basic prime conditions? And with that prime conditions, you apply this and substitute in the general equation. Then you are going to get one equation. If at all any problems comes, so the parameters of steady flow energy equation for boiler, the parameters are like this. H1, H2 are like this. Find out the heat. So in that, you are based on that parameters, you directly apply that equation. No need to derive this equation. Okay. So based on these parameters, now we are applying to this general equation. So this is a generalized steady flow energy equation. Okay, so keep it in mind. So here work done is 0. So this parameter I am going to get 0. Okay, so condition steady flow energy equation for boiler, Z1 Z2 neglected. Why? Because Z1 equal to Z2, Z1 Z2 are occur. And what are the parameters remaining? V1 Q plus M into V1 squared by 2 equals to M into V2 squared by 2. So now look in here. I am going to write and so look at here, Q plus M into H1. Now I am taking H1 to other part. This V1 squared I am taking this as outside. M into H2 plus V2 squared minus V1 squared by 2. Can I write like this? I am taking this v1 square to this side, and both sides m is common. Okay. Now can we generalize further? Can we generalize further this equation? Now look at this equation. So I am taking this h1 also to this side. Okay. So again, so q is equal to m into h2 minus h1 plus v2 squared minus v1 squared by 2. Okay. So this parameter is 0. Why? Because the basic kinetic energy v2 squared minus v1 squared by 2 is neglected as 0. So q is equal to how much? M into h2 minus h1. Okay. So this is your final equation, boiler. Okay. Okay. Can you do it? Okay. So first you note down the conditions. The work done is 0, z1, z2 are neglected. So why? Because the mass of fluid entering the system, leaving the system. So at the same time, kinetic energy is v2 squared minus v1 squared by 2. Okay. So this is the final equation. Okay. Q. If at all any question comes, the final enthalpy and initial enthalpy, mass is given to you. What is the heat output of the boiler for the steady flow? For the steady flow process in a boiler, then you are supposed to apply this equation. Okay. Now let us say further how this steady flow energy equation applied for nozzle. How this steady flow energy equation applied for nozzle. Steady flow energy equation for nozzle. Here the velocity flow through the nozzle is high. So here Q is 0 and work transfer is 0. Okay. Heat is 0 and work is 0. Okay. So V1 is small and can be neglected. These are the conditions you must know. Okay, for nozzle, what are the conditions? For boiler, what are the conditions? You are supposed to keep it in mind. Again, in coming classes, especially in third year, you are going to study entire levels coming in next semester or in third year. Boilers, one separate topic is there, one unit is there, and if you want to study further at nuclear final year, one of the elective subject is there, non-conventional energy sources, where we are going to get power. So based on thermal power, tidal power and geothermal power, there you are going to study entirely 4 units, entire subject on boilers, different boilers, nuclear power plants, thermal power plants, how power is generated, all these things again in detail with the almost boilers, one separate large books are there. Okay, again nozzles. Okay, in third year or next semester you are going to study in detail what is nozzle, what is the purpose of nozzle. Okay, what happens inside the nozzle. Okay, all these things you are going to study in detail. Okay, so don't confuse. Especially in this class we are applying general equation for boiler and general equation for nozzle. Here again apply this one. You can apply this equation to wait. I am going to write this equation again. So Q plus M into H1 plus Z1Z plus B1 squared by 2 equals to W plus M into H2 plus Z2Z plus V2 squared by 2. Okay. Now applying static flow energy equation for nozzle. Velocity flow through the nozzle is high. So therefore these two parameters are 0. Q is equal to 0 and work done is 0. These are the conditions. Okay. And V1 also neglected. So this parameters Q is becomes 0 and W is becomes 0. So what are the remaining parameters? V1 also neglected, Z1, Z2 also neglected. Okay, so the final equation M1 H1 equals to M into H2 plus V2 squared by 2. Okay, this is your final equation. Now you bring back this one, you bring back H1 to this side. M into H1 minus H2 is equal to V2 squared by 2. Okay. Now taking 2 like this. Wait, 1 second. Like this. Like this. Sorry. Okay. No problem. Taking 2 here. 2 times m into h1 minus h2 is equal to v2 square. Therefore, v2 is equal to 2 times m into h1 minus h2. Okay. This is your final equation. Okay. Regarding this is your final. Now let us see this one. Study for energy equation for nozzle. Velocity of flow through the nozzle is I. Q equals to 0 and W equal to 0. I am striking this one, I am striking this one. Z1, Z2 are neglected. So V1 also neglected. Okay. So V1 neglected. Therefore, what is the final equation? The left side M1 H1, the right side M into H2 plus V2 squared by 2. Okay. I am taking H2 to this side. Okay, like this. 2m into h1 minus h2. So this is your final equation. Generally, if mass is equal to 1, V2 is equal to, if mass is 1, 2 into h1 minus h2. This is the final equation. Next class we will see the study for energy equation for turbine or compressor. Okay, thank you.